Good evening, everyone. Am I audible?
Yes, sir.
Yes, sir.
Good evening, everyone. In this
Good
session,
evening.
we have with us the resource person, Mr. Shishir Deshmukh. He is a very good example of what an amateur astronomer can do. Now, it is said astronomy is the only subject where amateurs are equally respected as professionals. And you will see that from his work that I'm presenting and then supported by his talk. He, by training, completed BCom, later completed Master in Library Science, also did Diploma in Computer Education, and then MPhil in Information Science. He truly got inspired into astronomy, worked with Akash Mitra Mandal Kalyan, became the first Indian to discover sun-grazing comets using data from NASA and ESA's SOHO Observatory, which is called Solar and Heliospheric Observatory. Till date, he has discovered 8 comets using SOHO data, and that is the record held by any Indian. Later, he moved on to other projects, successfully reported about dozen uncatalogued minor planets to Minor Planet Center using data from NASA's NEAT imagery. He will talk about some of these things in his talk, that how reporting becomes very essential because most amateur astronomers go for stargazing, enjoy the sky, okay, but many times the meticulous work is not done by many amateur astronomers, but you will see that how recording and meticulous data has to be kept, and then it can be reported to the respective authorities. He successfully submitted the observations of various meteor showers, Leonids, Geminids, Eta Aquarids, Taurids, Monoceratids to International Meteor Shower IMO body. He submitted 100 plus photometric observations of short period variable stars using DSLR camera to American Association of Variable Star Observers, famously known as AAVSO. Successfully submitted observations of asteroid occultations to International Occultation Timing Association, IOTA's regional coordinator at Japan, the highest number of observations reported by any individual in India. He also was invited by ISRO's Instrumentation System Unit, IISU, to talk on DSLR photometry on 26 July 2017 on the invitation of the director IISU. He has submitted photometric observations of minor planet 300 Geraldina during its occultation during Venuvapu Observatory, Kavalur in Tamil Nadu on 3rd April 2020. He has published multiple papers in various scientific journals. So as an amateur, he has continued publishing papers in amateur journals, recipient of Astronomical Society's award, and then various different awards from important bodies. One I would like to mention, he was felicitated by NGO Arohan on 1st March 2011 by hands of the former President Dr. APJ Abdul Kalam. He also has published 2 books. One is on eclipses. He co-authored the book with his teacher mentor in astronomy, Mr. Hemant Mone, Astronomy of Eclipses. And he has also published Astronomy and Space Research Puzzle book in KDP publishing platform. He has published multiple papers. Those papers involve early 60-day observations of a particular nova, V55668 in Sagittarius using DSLR camera, measurement of 100 critical minor planets from NEAT archive, measurements of 60 double star systems using a small telescope and 4 different methods, then Pluto's atmosphere in plateau phase since 2015 from stellar occultations at Devasthar, in the morning, Dr. Virendra Yadav talked about Devastar Observatory. So we have got an amateur astronomer who has worked over there. And then he has also published papers on in popular science articles in many magazines and like Science Reporter and other magazines, where he has written a number of articles on observations, meticulous observations about occultations, eclipses, and photometry. So we have one of the best amateur astronomer with us. So welcome, Shishir sir. Okay, and the forum is yours.
Thank you very much, sir. Am I audible, sir?
Yes, sir.
Yes. Thank you very much for that introduction. And good afternoon, good evening to all of you, all of the participants who I learned that who are from different streams, predominantly from physics, but from different streams as well, and also from different age groups. So what I think, my first impression was that what brings all of you here is the common interest in the science. And as far as this lecture is concerned, this will be all about the asteroid occultations. And uh, Professor Shetty sir gave me little idea about the audience, how learned and how interested and how enthusiastic you all are. And since you are from different backgrounds, I have customized my presentation a bit just to have basics, right, from the basics to a little bit advanced. So it may be possible that some of the concepts which I will be explaining may be known to you, or some of you may be aware of them, but in the general interest, I think you should not have any objection to that. So, so thank you very much. Uh, we'll start. We'll start our presentation. Let me share my screen. I'm sorry, I'm not much used to Zoom, so I'm just searching around where is the presentation option.
Sir, at the bottom you'll find share screen button.
Okay, yeah, got it. Thanks.
And if there is any audio, then you can, while sharing, you can check that box
Okay.
of share audio or video.
Okay. Okay, got it. Okay. Okay. So hope this is visible to you.
Yes, sir. Visible.
Thank you, sir. Thank you, sir. So today we will be talking about the observations of stellar occultations by asteroids. Sometimes it is also called asteroid occultation. So basically, these are the kind of eclipses, kind of an eclipse by an asteroid, which is a solar system body, to a star, which is far more distant outside our solar system. So both terminology should be okay. It can be stellar occultation by asteroid or simply asteroid occultation. So both the meaning is the same. So just to give the background, what are the minor planets? So we all know since our childhood or from our school age that there are planets, primary planets in our solar system, and besides those planets, there are minor planets as well. So basically, these are the minor, much smaller objects in the solar system that are revolving around the sun, just like major planets. They are also revolving around the sun. So these are asteroids or minor planets. Both terms are, the meaning is the same. And these minor planets, although practically they are spread throughout our solar system, their main distribution is predominantly situated between the orbits of the Mars and Jupiter. So their main population is revolving around the sun from the orbits between the orbits of Mars and Jupiter. So those asteroids which are hurling from that location are collectively called as main belt asteroids. So as I said, these main belt asteroids, you can see here. So you can see here, the main distribution of asteroid is between the orbits of Mars and Jupiter. This is the Jovian orbit, Jupiter's orbit, and this is the Mars orbit. So most of the asteroids are revolving around the sun from this area. So these are called main belt asteroid or main asteroid belt. And as I said, however, the asteroids are spread across the solar system. There are many asteroids which are having very enigmatic or elliptical orbits, and those they are even crossing the orbits of major planets also. So asteroids are very common in solar system, and from the amateur astronomers' perspective, I would say uh, asteroids or minor planets are extremely important because they give us plenty of opportunities to work, to do some research oriented work. So those are very important for us, and of course for astronomers as well. So now we will come to the core topic. What is meant by the asteroid occultation? So we all are aware of the eclipses when three bodies are there and one body comes in between the line of sight of the two bodies, and that's why we see eclipses. So when it comes to full lunar eclipses, then it is the Earth which is between the sun and the moon, and a shadow falls on the moon, and we see lunar eclipse or eclipse of the moon. In case of sun, solar eclipse, what happens? It is the moon that comes in between Earth and the sun, and its shadow falls on the surface of the Earth, and we see a solar eclipse. It's nothing but a matter of light and shadow play, we can say. So similarly, since there are hundreds and thousands of minor planets moving in different orbits around the sun, quite often it happens that they come in between the Earth and a distant star. Um, so at that time, what happens? They can temporarily eclipse the star. So you can say that this is a kind of a special kind of eclipse. So this is the Earth, and this is one asteroid which is also moving around the sun, just like the Earth. And this is the direction where my cursor is. This is the direction of a star, a distant star, which is far beyond the solar system. And during the course of its orbit, this asteroid comes in this way, wherein the starlight is blocked by that passing asteroid, and the people living in this region of the world will temporarily will see that the starlight is blocked by this asteroid. So this is all about the asteroid occultation as a concept. In the next slide, I will try to give you a little bit more idea about how it looks as seen from the Earth or from the observer's perspective. So as you all know that asteroids are much smaller, as I said, much smaller bodies as compared to the primary planet. And these asteroids are also by shape, also they are not perfectly circular. In most cases, rather, they are very odd shaped rocks or odd shaped objects. So I have made a small animation here. This is how it happens as it hurls in the space. I will repeat it. a star which is fairly stationary. Asteroid, while traveling in its orbit, temporarily blocks the light of the star, and this way we can see an asteroid occultation. So it is temporarily eclipsing that starlight, and usually it is just a matter of few seconds. Since asteroid is a small object and the star is also a point source, their occultation, their kind of eclipse, is a very transient phenomena. So in the previous slide, I showed you the very ideal scenario wherein a large asteroid eclipses the star, a bright star. But typically, uh, most asteroids, as I said, are very small. They are very faint. Most of them are not visible to amateur telescopes. But yet, you can see this kind of event where asteroid is barely visible, or even or not at all visible, but you can see the eclipse. So I would suggest you to focus on the star itself. Don't hunt for the asteroid. Just look at the star and see what you see. Sorry. See, temporarily it lights gets fluctuated, or it vanishes for a while and then reappears. So this event is called occultation. Occultation. So bright star occultations are obviously very rare, although asteroids are spread across the solar system, as there are too many in number. But bright stars occultations are very rare because bright stars are very limited. Very hardly 20 bright stars are there, which are visible by unaided eye. Although there are several hundred stars which are visible to naked eye, but usually the asteroid occultations occur to a very faint stars because they are just too numerous. Faint stars are too numerous, so that's why faint star occultations are much more common than the brighter ones. So typically, as we know that in case of an eclipse, there is a path of eclipse. For example, in solar eclipse, when the moon's shadow falls on the surface of the earth, what happens is that due to the motion of the moon, it casts a shadow on the surface of the earth. See, so as the moon is orbiting around the earth, when it comes in the plane with the earth and the sun, its shadow is falling on the earth, and as the moon is traveling in its orbit, its shadow casts a path across the surface of the earth. So similarly, the same way the path of the shadow of the asteroid can also be drawn on the surface of the earth during an occultation, just like this. So this is what professional astronomers do. They compute the orbital parameters of the asteroids. They check the positions of the stars, and then they see whether a particular star is being occulted by any asteroid. And then they compute the path from which part of the Earth will be under this shadow. People living only within those shadows will be able to see the occultation. All the people who are outside the shadow, they will not see occultation, because for them a star will be visible throughout and there won't be any eclipse. It is only this narrow strip, the people living within this narrow strip will be able to see stellar occultation. And there is a reason for this, because since minor planets are very small objects, typically their shadows are very narrow, very small. So typically this path, most asteroids are few tens of kilometers. So the typical width of the shadow shadow band is in the order of few tens of kilometers, as it is directly related to the size of the asteroid. And this also should be noted that any uncertainties in the orbital parameters of the asteroid, the actual path may shift hundreds of kilometers either side of the predicted path. Since asteroids are far away from us, beyond the orbit of typical asteroids, beyond the orbit of the Mars, any small deviation in their position or uncertainty or error in their position would put the path of the shadow literally hundreds of kilometers either side of the predicted path. So for an accurate prediction of the asteroid occultation, its orbital parameters must be known with great precision. We'll come to that point a little later. So now the big question, what is expected from the observers? What is expected from the observers? Because observers are all over the world. Professional astronomers have got their own setups. Large observatories are there. But as you have seen in the previous slide, asteroid occultations are seen from a narrow band of its path. So professional astronomers will not always have the liberty to take their telescope and go to the path and see the event, because the observatories have fixed setup. These are large observatories. Those are static observatories that cannot be portable. They are not portable. They cannot be moved. So astronomers, here comes the role of amateurs who are having mobile setups, who are having a portable setup. They have got their small telescopes. So if you have a small telescope like 6-inch, 6-inch or 8-inch telescope with a fairly sturdy tripod and drive, with a dark sky available, you can see a star which is 100 times fainter than the star which is visible by naked eye. So amateur astronomers have got this advantage over professional astronomers. They have got portable setup. They can go to the path and see the event. So what is exactly expected is that this is the path, this is the center line, suppose, and typical, for example, say this particular asteroid has got a path of, this event has got a path of, say, width of it is 15 kilometers only. So ideally, the observers should spread across its vertical cross section of this shadow path, because each observer will have a separate cord. Each observer will have a separate cord for its observation, and you can see by the shape of this asteroid how important it is to spread across the path. So now in this case, you can see that this observer, I think I lost the number somewhere, but this is observer 1 and this is observer 5. So observer 1 and 5, you can see that they are outside the shadow. You can see that they are outside, well outside the shadow. So what will happen, as I said earlier, those who are lying outside the shadow, they will not be in a position to see the event, because for them, there won't be any obstacle to the starlight and there won't be any eclipse for them. But despite of having no event, they are very important. As you can see that they can limit the size of an asteroid. They can limit the size of the asteroid. So that is very important.
Sir,
these are called negative. Yes.
Is it okay to ask questions in between?
Yes, yes.
Okay.
Yes, I'm okay. I'm okay for that.
Okay, so here a question is this elliptical shape due to shape of asteroid, or it will be also because of the spherical shape of the
Curvature.
surface, curvature of
Yeah,
the.
yeah. Yes, yes. Both the things. No, it's a good question. Both the things are in place here. Typically, while if the asteroid profile is unknown, at the time of computation, a circular profile is assumed. A circular profile is assumed, and uh, the event parameters are calculated, and the path is also calculated on the surface of the Earth. So now, this particular slide, towards the beginning and end of the path, as the path is touching the earth, and as it leaves the surface of the earth, at both these locations the shadow will be elongated, because it will be the shadow will be falling with an oblate and with a very steep angle. So that's why towards the start at the start of the shadow, when it is touching the surface, and at the end where it is leaving the surface of the earth, on both locations the shadow will be elongated. But there is also one more thing contributing to this, is the shape of asteroid, because asteroids come with very varied shapes, circular, elliptical, potato shape, cigar shape, or even dog bone. So many shapes are they come in. So for the calculation purpose, circular profile is taken into account, and computations are done. And when the observer, the observation results of observation data of these observations are put together, the actual profile comes up. We'll come to that in the later the forthcoming slide. Is that answers?
Yes, sir. Thank you.
Yeah. Okay. You may please interrupt me and ask the question. Okay. So now, very important points. So this is a slightly surprising fact. We are talking here about asteroid occultation, and I'm saying that it is perfectly fine if you do not see asteroid itself. This is because we should always be interested in the star, although we are trying to understand the profile of the asteroid. It is the starlight, and the fluctuations in the starlight that will give us idea about the asteroid. I will clarify this point later on a little bit more, but it is fine if the asteroid is not visible. Rather, in most cases, asteroid will not be visible, because these are very small asteroids, very distant objects. So from amateur telescopes, typically these asteroids will not be visible during the event. So what is important here is the star. You must check that the star's magnitude, which is the apparent brightness of that star, is within the observable limits of your setup. As I said, from a dark sky, a 6-inch or 10-inch telescope can show you a star of around 10 magnitude or even 11 magnitude star. So if this occulted star is of 9th magnitude, you can definitely go for this event and try to observe it. But if the star itself is a 13 magnitude object, which is very faint, then it is beyond your observational setup, your observation setup. So in that case, you will not be able to see the event. So you should know the observable limits of your setup, up to 11 magnitude, up to 12 magnitude, likewise. So now, asteroid is not visible, that is fine. Star should be seen, that is also fine. But what needs to be noted? So here is the take-home point. For any scientifically important occultation observation, only the time and the light output of the occulted star is to be measured as precisely as possible. Time means the actual time of the start of the event and end of the event with as precisely as possible, and the light output. If you are taking photographs, you should put that in the video mode. You put your camera in the video mode, and your frame rate. Those who are familiar with the photography or videography, they may be aware that there is something called FPS, frames per second. So if your typical standard camera, DSLR camera, offers 30 FPS, that is 30 frames per second. So put that to the maximum level, but ensure that at that such a short exposure, that faint star will be captured. Otherwise, there will be a blank. If the photo, your camera is not sensitive, the sensor is not much sensitive, then the faint star will not be captured. So that you'll have to do some uh, preliminary work, because that star is always available. Once you know the date, supposing next week there is an event, there is a prediction of an event, then from today itself, you can start monitoring that star, how it is, where it is exactly in the sky, in which constellation. Then you try to locate that through your telescope, see how faint or how bright it is, what are the nearby stars, how to identify that star in the realm of other stars, and is check if your video can capture it at the fastest rate. If not, then what is the bargain? What is the fastest rate at which you can still manage to capture it? That you have to do some working before the actual event. Now, this variation of the light output can be measured precisely by imaging and analyzing software. However, measuring the time of ingress and egress is a bit tricky. I'll come to that when we discuss about the technicalities of the observing method. Now, this is very important. The desired accuracy of the time is in the order of milliseconds, because any error in the time of ingress, that is start of the eclipse, and egress, that is the end of the eclipse, any error in the measurement of ingress or egress time will uh, will literally put your analysis for a toss, because your inferences will be erroneous. Okay, so now we understood what is the basic concept of asteroid, what are asteroids, what is the basic concept of asteroid occultation, what is to be observed, what are the two important things to be observed, time and the light curve. And now let us try to understand its scientific value. Why asteroid occultations are important? Why asteroid occultations are important? Now, first and foremost thing for amateurs is that gives a great opportunity to the amateurs all over the world to create a scientific data. So nothing matches this, because see, leave aside whenever you are working in such a field, astronomy or wherever, uh, uh, getting a credit of a discovery is a different thing. It should always be a byproduct. Your main aim should be to give a scientific output. That is most important. You should try to produce a scientific data which would be very useful for professional astronomers to draw some inferences. It is not necessary that you should do all the scientific analysis work and try to break your head against the wall and try to get some information and inferences out of it. You may restrict your work to the data taking process. Observe the event as precisely as possible and share the data with the authorities, and there are professional astronomers who will take care of the rest. So this is very important. Now, as I said, these such predictions, asteroid occultation events need accurate predictions, because these are very small bodies in the solar system. they are, although there are, to my knowledge, there are more than 5 lakh known orbits of minor planets in the main belt of asteroids. This is quite old figure. I tell you, over and above that, there are much more than that maybe. But I'm on the conservative basis. I'm saying that there are 500,000 asteroids with known precise orbits. That is one thing. And then there are hundreds and thousands of stars whose positions are precisely known. But yet, having said all these things, both these things are required prerequisites of the predictions. Yet, there can be some error that can really put your observation for a toss, or your prediction for a toss, because we have personally experienced this. We traveled hundreds of kilometers to the neighboring state, try to observe an event, and that event did not take place at all. And then we understood from the professional astronomers that there was a slight error in the prediction. So that slight error cost us a lot. So if you are going for a big event, or the event that needs a lot of travel, get the confirmation again from the professional astronomers. So what is the outcome of that? Even though asteroid occultation was not seen from the predicted location, that means there is an error in the previously known quantities. So because of this occultation, even professional astronomers could get a learning curve that we are still not there. We need to have more precise observations, more precise predictions. So that gives opportunity, the opportunity given by the asteroid occultation. Now we can provide the insight to the dynamics of stellar system, hidden companion, dimensions of stars. This is also one of the important relics of the occultation observations. Time and again, it has been proved that precise observations have led to the discoveries of the new stellar systems, new companions, even the moons of asteroids. We'll come to that. Now, as I said in the earlier slide, if there are multi-chord observations, observers spread across the vertical cross sections of the occultation path, then collectively their data can provide a very good profile of that asteroid. Again, I will come to that portion in the forthcoming slide. Yeah, as I said, this observation has there are plenty of examples where the occultation event has led to the discovery of satellite to the asteroid. So those who are novice to this subject, let me tell you that since we have our own natural satellite, the moon, the Earth has got moon. Many major planets have several moons. So asteroid are not exceptions to this. Many asteroids have moons. There are few asteroids which are having even multiple moons. And most of these discoveries have been discovered while observing the occultation event. How? We'll come to know that. Okay, so this is what I was talking about, the asteroid profile. So you can see, okay, so you can see that this particular asteroid, remember, asteroid name is always the number is followed by its name. Not all asteroids are given specific names, but yet most of them are having their specific name. So 9 is the number and Metis is the name. 9 Metis, this asteroid was occulted a star, and what happened is that this event was observed by a number of observers across the path. And you can see that this particular observer who is at the north, he did not see any occultation, but his uh, his observation is very important because it marked the boundary of that asteroid. And then just try to remove this profile, a blue line, and then you will see that some figure is automatically uh, came out of this data. Although there can be some errors, or it may be ill-shaped asteroid also, but still this particular profile fits well to the observed data, right? So this is how asteroid occultations are important, because they will give you the idea about the size and shape of the asteroid. We'll again see one more example. Okay. For example, another asteroid 90 Antiope. This was also observed by a number of observers, and then its profile was drawn. It is an irregular shaped asteroid. 57 stations observed this chord. See, this is where I feel very sorry that in our country, despite of having a huge geographical expanse, very few observations are made. And since India is geographically wide and tall, we have plenty of opportunities, plenty of paths. Every night crosses the Indian subcontinent, but still we are all missing them. Okay. Now developing asteroid profile from the observation. This is the one which we saw in the last slide, and then how you can apply the profile. See, there are few asteroids which are closely photographed. Very few asteroids. I repeat, there are very few asteroids which are directly photographed by spacecraft or by large observatories. Very few. But with the help of asteroid occultations, what you can do, you can use or apply those photographs to these profiles so that it will match the observation data, and you can get the confirmation that at the time of the event, the orientation of that asteroid was this. See, these asteroids are also rotating around its own axis. So sometimes since they are of irregular shape, their profile is a bit complicated, but still you can have a 3D models. There is a software called a DAMIT, which applies the models of asteroids to the observation data, observed data, because they have got models, photographs of asteroids from a different angles. So what that software does, it allows you to rotate that asteroid to match the observed profile. Are you getting my point? So this is how the software or the latest technology can help you to understand more about the asteroid. But here,
Sir, there is a question.
Yes.
So where do these occultation predictions come from?
Okay. We have a separate section for that in the forthcoming slide, how these predictions are made, who does that, and what are the parameters. If it is fine, if I explain that there.
Okay, sir.
Yeah, I'll come to that. If I forget, please remind me. So now we'll move ahead. Discovery of moons to asteroids. As I said, having a moon is not an exceptional phenomenon. It seems that it is not an exceptional phenomena. It seems to be a relatively common phenomena in the solar system. Many planets are having huge families of satellites or moons. And so likewise, large asteroids are also having as one or more moons. So what is the importance of occultation in this context? It is very, very interesting. Let me show you. I'll try to have tried to this. See, supposing you're observing this star. Now there is an occultation. I'll come to that again. This is the star, and this occultation is happening. And what happened here is you have this star was occulted not only by the asteroid but also by the moon, by its moon, right? So what will happen? See, please understand that although for the understanding purpose, I have shown here asteroid and its moon, but in reality, while actually observing in the sky, these objects are so small that they will not be visible. What all will be visible is only this star. So what you will be observing is nothing but this graph. This graph. This is the light curve. While after observing the star, after taking the video frames, when you put this to analysis software, it will give you this light curve. And there is a very interesting phenomena in this light curve. You can see that the star's light, although this is quite noisy, but yet the starlight is relatively stable here because the occultation was not in progress. And then at this moment, the occultation started. Star was completely blocked, so the light output was zeroed. It came down, and then again it regained as the occultation ended. But then after that, again there was a small dip. There was a small dip. You can see that, and then the star's light got restored. So what this kind of light curve shows is that apart from this primary event, there was a secondary event. There was a secondary event. That means there is a possibility that asteroid is having a moon which occulted the star after the main event. See, I think you will. I try to put the things together so that
Just
you will get
one
idea.
one comment here.
Yeah.
In your animation,
Uh,
that practically the star will be a point object. So even with that small satellite of asteroid, the star will be completely blocked effectively, right?
uh, uh, not always, because not always, because star, no matter we say that in general parlance, we say that star is a point source. But
A point
if
in a
you
sense
take,
of
yeah,
arc second or something like
arc
that,
second, yes, yes.
or fraction
So
of arc
typically,
second.
absolutely. So these asteroid moons are so small that their diameters are sometimes smaller than the star's diameter, star's
Okay.
apparent diameter of
Okay.
few arc seconds. So that's why you can see in this case, in this case also, in this case, it is almost zero. So it is as good as completely blocked. But in some cases, the drop is much shallower than the main event. So in that case, it is a partial eclipse, we can say, or annular eclipse of the star by an asteroid moon. So at that time, this drop will not be as deep as this, but it will be much shallower than that. So so that way it is. And good that you someone raised this point, because stellar diameters are also taken into taken into consideration while making precise predictions, because there comes the uncertainty, because sometimes stellar stars are so their atmosphere are so tenuous or so difficult to predict. It is very difficult to predict their precise uh, angular diameter, apparent diameter, of course. for the occultation purpose. So that's why there is a uncertainty flag in the occultation prediction. When there is uncertainty, there is a flag that there can be the position of the star, the precise center of the star may not be as accurate as it is predicted. So that uncertainty flag is also one thing that we need to take into account while setting out for observation expedition. Okay. So yet another area where the occultation astronomy can give you fantastic results. Just have a look at just have a look at this light curve. So this asteroid 400 Emita, this asteroid occulted this star. This is a Tycho catalog, a remote star in the Tycho catalog. And what happened here, you see, the star's normal light was this. Then it took a dip, and then again took a dip, and then it was completely vanished. And then while coming back also, restoring also, it came in the steps. You can see a step profile here, step profile. So in the earlier case, the starlight was dropped directly and regained directly, correct? But in this case, it vanished in a step-by-step mode, in one step. So what does it mean? What does it mean? So if you have such kind of diagram, light curve, then you ought to pay a lot of attention to it. And what astronomers do is they try to build a model of that star that can explain these steps. So on the basis of this, I don't know what, I did not see the profile of that star, but I tried to see what must have happened. These are the different stages of that occultation. And the same diagram, I have stretched it to match these different steps. So now my assumption is that that star was a multiple star. It's a double star. But either they are very closely placed, so closely placed, and there are plenty of such examples in astronomy. The double stars are very closely, some double stars are so closely placed there that they cannot be resolved even with big telescopes. So what happens here is, in this stage, so just correlate each phase. These are the 5 different phases of the occultation event. And underneath this diagram is also having 5 stages, 1, 2, 3, 4, and 5. So just I tried to correlate what must have happened here. Here, occultation yet to begin. And then here, primary star, the one star which is a brighter one, that must have occulted first, because the drop is more in this case. See here, the returning step is a bit shallower than the dropping step. So the brighter star must be the first one that must have occulted. Then in the third stage, both these stars were occulted. So that's why it's a flat line. And then while returning, there was a lot regain as compared to similar to, just as this drop is there, this rise is there, because the brighter one came into light, and then the shallower rise, which is the secondary one. So this is how astronomers try to build the models, theoretical models of the star systems by occultation observations. So so your observation needs to be very precise. In this case, this observation is excellent because there is very little noise. So if your system or your observation data is very noisy, then you will have lot of up and down lines. So in those up and down lines, this step event will be merged and you will not come to know. So that's why your data needs to be very clean. Your noise level should be at a minimal step, minimal. It should be very minimal. So now we come to the methods. Evaluation of the method of observation. So there are many methods of observing the occultation. And of course, the methods which are not recommended by International Occultation Timing Association, that is IOTA. IOTA is because these events, the data from these events will be of very poor quality, and there won't be any valuable inferences that can be drawn from these data. If you are just a casual observer, then you may continue watching event using these methods. But if you are serious enough, then you should have some technical know-hows, and you must gain some expertise to use them. So stopwatch, what it is for, at the time of ingress, you should click it, and at the time of egress, you can again click it, so that both the ingress and egress time will be recorded. But again, since this is a manual method, there is a personal equation which person to person, your hand-eye coordination, your response time will vary. So that will put uncertainty in your data. The case with eye and ear, the one observer will say yes, ingress, then other one will record that time. So this method is also less reliable because there is a personal bias involved in this. Recording assistant and recording at the start of event, someone will say start, then recording device will be started. But again, this is also a less reliable method. Then internet and computer. Although we feel that computers and internet are very good tools, in this case, they are not adequate because there can be a lag of the processing lag in the computer or internet transmission that will add the unnecessary delay in the event timings. So that is also not recommended. Yes, tape recorded, then drift scan video and time inserted video. Time inserted video, this is the method, the last one, which is highly recommended by IOTA. And this is the method that we use for observation because it gives the fairly scientific and fairly accurate data, I would say. We'll come to that later. The next slide. Time inserted video method. So for this matter, as I said, there is a special camera that is a highly sensitive camera capable of capturing video at 30 fps, that is 30 frames per second. So now you can say that someone can argue that even our standard camera is capable of 30 fps, right? Or even more, I don't know. But there is a difference. Our standard cameras are meant for outdoor photography. Here, we are taking photographs of a very feeble light, a very dim starlight. So that's why your camera sensor has to be extremely sensitive to light, extremely sensitive to light. So this particular camera, which is designed for occultation observation, is capable of taking 30 fps photograph and still managing to capture a star of 12th magnitude, which is much fainter than naked eye limit, much fainter than naked eye observing limit. So that makes this camera a little special for occultation observations. The approximate price in Indian rupees of this camera is around 11 to 12,000 rupees. But this has to be imported. It is not according to this company. If you put this to Amazon, they will show you such kind of things. But beware that these cameras are a little different from their similar cousins, which are not used for scientific purpose. So just go to IOTA site, International Occultation Timing Association. They have recommended where to buy this. Please get those camera from that site only, because they are customized for occultation observation. Now, this is yet another unit which is designed by IOTA. I mean, IOTA recommended this. What this does, VTI means video time inserter. So what it does, the frames which are collected by this camera are sent to this device. This device, what it does, rather this device puts up the timestamp on each frame collected by this camera. I repeat, what this VTI unit does, video time inserter unit does, it inserts timestamp on each image captured by this camera at 30 fps. So this is extremely useful, because on each frame you will have timestamp, so that what will happen, the frame on which the ingress or egress has happened, that you will come to know immediately by seeing this timestamp. We will see one video so that you will have some idea how it happens. Then there is a software that extracts that analog data to digital and converts that data into digital, and then creates a CSV file that can be used for analysis. And then obviously there are many analysis softwares that analyzes the data or CSV files, where the actual depth is, what is the noise, how much is the noise, what is the standard deviation, and all those quantities, mathematical and statistical quantities, are computed using this software. There are a couple of softwares that does this activity. As I said, this is a Runcam Night Eagle Pro highly sensitive video camera capable of recording 30 fps at resolution 460 into 640. You don't need a very wide area for occultation work. Your occulted star, couple of reference star, that's it. You don't need entire constellation to photograph. So that's why limited view will be very ideal, because that will reduce the pressure on your processor to send the data to the processing pipeline and the computer. So that will be very useful. Yeah, so this camera can be fit to the prime focus of the telescope. Prime focus means the where you see the object, the objective, the rack and pinion. On the rack and pinion, you can place this camera, and you can see that image on the computer screen. So this is Astro edition. As I said, this is customized astronomy edition of this camera. So IOTA has developed their own capture software that has got basic functionality to observe the event for occultations. But yet there are other softwares are also which are slightly better than capture, I would say, like SharpCap and APT. Those can capture those images also. VTI, as I said, this is video time inserter, accurate. And the one thing I forgot, this time is taken. There is a GPS receiver in it, so that's why the time measured or used by this video VTI unit is taken from satellite. So it is a GPS time. So it is very, very accurate. So there is a position mode also in a VTI unit, so that the location where you have set up your telescope to, that location also precisely, its GPS position will also be latitude, longitude with precise position will also be noted, and then the actual time is also captured on each frame. So there are a couple of softwares that can have a capability of analyzing this data. These softwares can uh, take the data in CSV form and give you the light curve, and they can give you, even these softwares, some of these softwares are capable of identifying on its own the possible event, when the dip where the dip is there any secondary event, all those things that software can give you readily data of. What is the data SNR, that is signal to noise ratio, then what is the confidence level of the disappearance and reappearance of the star and reappearance of the star, that exact timing, the confidence level, everything which will give the magnitude drop, the duration of the event, everything it will compute for you.
Sir, there is a question.
Yes.
Can we use the same setup, apparatus, and workflow to study variable stars?
Yes and no. Yes, for the reason that there are extremely short period variables which requires high cadence to monitor the light fluctuation, especially the cataclysmic variables or the eruptive variables or some nova candidates, wherein so many events are happening with a haphazard rate. So at that time, you can monitor them using this camera, but we have never done that. To be frank, we have never done that. The one probable limitation can be that the field of view of this camera is very less. I guess, if I'm not wrong, it is 7.5 arc minutes. So it is too small. So for variable star study, you need to have a reference star, check star, rather a couple of reference stars at least, and with varied magnitude, so that you can bracket the your variable star, fainter and as well as brighter star also. So all this cannot be captured with a very limited field of view. So that will put some limitation to your variable star observation prospect for this, for using this camera. But there is a very good application, another application of this camera, and that is meteor shower observation, because these are highly sensitive cameras, and along with this camera there comes a fisheye kind of lens. We have not even have got any opportunity to use that, but if you put that camera open in the open field, it will capture it. It is expected to capture bright meteors. So that can be used for that purpose. It can be used.
So can this be used to make that all sky camera setup?
Yeah, something like that. But since we have never used it, I guess we need to check the possibility how it looks good.
Okay.
If how much of the sky it covers, and how much faint meteor it can capture. I don't know, but yes, it has that capability. So there must be that application open for this camera. Okay, and the other counterpart is no, because most of the variable stars do not need high cadence. They do not need high cadence. So, few minutes, if the periodicity is in the order of few minutes, then few second cadence is good. If it is few hours, then few minutes is also good. If it is few days, then once a night is good enough. So all depends on the period of that variable star. Okay. Is that answers? Are there any further questions on the?
Right now, nothing in the chat. So I hope.
Okay.
It-
Okay. Okay. So, okay. Now predictions. We come to the predictions, and there was a question: who does
okay.
this
There is a
prediction?
question. There is a
Ah,
question, sir.
yeah.
Is it possible to do spectral analysis of asteroid with this technique?
No. No, because see, this particular camera is sensitive to take photograph of that to images of the photometry. Basic photometry you can do with this camera, but as for for spectroscopy, you need to have a much wider, yeah, wide angle wide angle cameras, because with spectrum, your spectrum of for spectral analysis, your setup and your camera need to be in sync in such a way that the stars which are at the limiting magnitude of your setup, you have to reduce, go further 5 magnitudes to have the spectrum of that star. Let me put it in another way, to make it more simpler. For spectral analysis, your you need to have uh, yeah,
So
you need to
we can
split
say
that
that the
light.
same light is broken into multiple
Yeah, broken
wavelengths,
into,
and
yeah.
therefore you
So
need more intense.
yeah, so that capability is not there, and that splitting of the light is not, that capability is not there, and field of view is also very limited. So for that matter, you need to have that special star analyzer kind of thing. For spectrum, I would recommend you initially go for star analyzer. There is something called star analyzer. You can search into the Google also. In that star analyzer will help you to take the spectrums of bright stars, like 20 bright stars, may say. So that preliminary spectroscopy you can do with star analyzer. We have tried it. But again, that has got some permutation combinations with your setup. So before purchasing that, you need to go to that site and put the values of your setup in their portal and check if that is working out. And then only you can purchase that star analyzer. Okay. So, okay. So let us go ahead. So the main authority, that is the international authority that is dealing with the occultation study, is the International Occultation Timing Association. I repeat, International Occultation Timing Association. This IOTA, in short, IOTA, uh, uh, IOTA is a preliminary. It is not a professional body. Let me tell you, but it is an unofficial or amateur group of amateurs, you can say, but on a very high level. Very experienced amateurs are there. Extremely experienced amateurs are there. Those who have made hundreds of asteroid occultations. Those who are working behind this IOTA body. We are in touch with some of them, and some of them, and those are, they are very helpful whenever you have any technical queries or queries regarding with respect to any predictions. They will always there to help you out. So International Occultation Timing Association has got many sections. For example, US, Europe, Middle East, then Japan, and recently India is also a node where the Pune Jyotirvidya Parisanstha is managing the Indian as an Indian node of IOTA. So IOTA is working all over the world. Since we have been doing observations prior to formation of IOTA India, we have been submitting our observation to IOTA Japan, and they are very experienced astronomers are there who are helping us to analyze that data also. And then these predictions are computed by some professional astronomers as well. like Mr. Steve Preston and Dave Harold. These are the stalwarts in this field. And these are the factors which are important for making predictions. The exact orbital elements of the asteroid. So you may be aware that in order to have the precise orbit of any particular asteroid or celestial body, you need to have understanding of the 6 Basilian elements of that object. So these asteroids are very faint objects, so their observation needs to be done carefully by large observatories, because most of these asteroids are beyond the observational limit of the amateur telescope. So these observations are done by large observatories, and their data is submitted to Minor Planet Center. Minor Planet Center is a body of International Astronomical Union, IAU. Uh, so Minor Planet Center has the authority of giving names. IAU is which again it is IAU. So IAU has the authority of giving names to asteroids. No matter how good or bad claims are being made, we give names to the craters. We can pay us, we can give the name of your so and so to some craters on the moon. They do not have any authority. Only IAU should have and is having the authority of giving names to celestial objects. Okay, so the positions of the asteroid at the given date, because on the date where that of asteroid exactly in the sky, that needs to be, you should be aware of. And then accurate position of the star, that is occulted body. So prima facie we think that stars are stationary, they do not change their position, that is fine. But still those who are studying astronomy seriously, they know that each star is also having their own motion around the center of our galaxy. And for this computation purpose, the proper motion, which is the actual motion of the star, annual motion of the star, that value needs to be accurately known to make the predictions. Then the path of the shadow across the globe, the the location from where the shadow is passing. Sometimes due to minor change in the any of these quantities, the path can shift to north or south of the predicted path. That has also happened. So these predictions, generally these predictions include a date and time of the event, designation and accurate position of the star, that is occulted body, designation of the asteroid, which asteroid is going to occult, then magnitude of both occulted star and occultation, magnitude drop in starlight, the path of the shadow from where it is going. And as I said earlier, it is not necessary to spot the asteroid itself. Only the drop in the magnitude of the target star is important. So this is a screenshot of simple. There is a software. I will let me tell you. This is a software which is advocated by IOTA and developed by one amateur astronomer. This software is called Occult Watcher. Occult Watcher, which is the link to which is available at IOTA site. You go to IOTA site, International Occultation Timing Association, put that in Google, go to their site. There is a whole set of instructions, information, notes about IO2 sections, journals, then instruments, and of course, the entire manual of occultation observation is also available on their site. Please go to that site and use that data before delving into these activities. So typically that occult watcher screenshot shows that the event time, there is a facility to put this email time in universal time also and local time also. An error, if any, then magnitude, the combined magnitude, stars magnitude, the constellation in which, and the position of the moon, whether the moon. This is also an important factor, because if there is a full moon very close to the faint star which is going to occult, then the observation prospects will be badly hampered. And then of course on the Google map you can have a track like this, the center line, which is shown in the green line here, you can place yourself somewhere around the center line, or if there are multiple observers, then should be spread across the vertical cross section of this path. Then reporting, as I said, this reporting is very important activity. You should submit your reports to any of the IOTA nodes, IOTA, International Occultation Timing Association, event details, observers. There is a specific template which is available on IOTA site that you should use, wherein all the data, required data is you need to fill in. And then once it is there, then at the Japan, where we submit IOTA node, where we submit our data, the list comes up, and your observation will be marked in this way. Your files and analysis files will also be there. This is the analysis. This is the summary of observation, successful observation. And then, okay, regional centers, regional coordinator. This regional coordinator who is sitting there, who is an extremely experienced observer. He checks that data, analyzes it himself, and then he puts that to on the node. If he has any doubts, then he places that data shares that data with the other IOTA experts, and they collectively take the decision if it is successful or it is a negative observation. So now this is interesting comparison. We have got huge geographical expanse, but we have only one station, and I mean one observer for this particular event. But for any small event, Japan is a very narrow strip here, but still there are many stations. So we have plenty of opportunities. Just to give you the idea, how one of the advantage of this occultations is that professional amateur collaboration. Amateur, as I said, as sir has told you, Akash Mitra Mandal Kalyan, which is the organization working in astronomy for last 4 decades nearly, they are observing, we are observing, I mean, I'm a part of Akash. So we are observing such events from many places. But if there is an event, important event, which is beyond beyond the capacity of our telescope, then and if the event is important, then we inform it to Nainital Observatory, Devasthal Observatory. We put official proposal to them, and then they observed this particular event because this was the event of occultation by Pluto of a very faint star, and Pluto's occultation was never observed from India at that point of time. Then on our request, other professional bodies were also involved, and this observation was done successfully. And this was the paper. Some international stalwarts were also involved. He is from Paris Observatory. And then this paper was published in APJ, that is Astrophysical Journal. This is a classic example of professional amateur collaboration, and with international campaign, you can be a part of international campaign using by this. And yet, just to
Sir, there is a
in the end,
question.
yeah.
Comment. Will AI be more helpful in this? And that is one comment.
Yes.
And second is, can occultation through space telescope be used to study very far away objects like Kuiper belt bodies and possibly extrasolar bodies?
Yes. Answers to both these questions is yes, definitely yes. As we know that this is the age, this is, I mean, this is the, I would say this is still infancy of AI, but yet AI is inevitable, and AI, you cannot predict what AI will do in next few years. You really cannot predict, but yet definitely it will. As I said, these analysis software are once getting that data, CSV data file, it analyzes that data and tries to check on its own where the event was in that data.
Can we say that now large number of people are doing astrophotography and stacking of the images. Those
Mm.
softwares are using machine learning or
Mm.
AI. Can we say that they are
Yeah,
already
we can
used?
say that. Yeah, we can say that.
Because you
I'm
need
not.
to correlate,
Uh,
you need to slightly adjust the image, rotate
yes,
that
yes,
image, and
yes, yes. There are many new softwares which are really very good at image processing. Uh, I'm not expert in that, but there are some people who I know who are in our language, who are very uh, abreast of all these latest imaging software, and it can be used for the purpose for which we are taking that data. For example, if you are taking for finer details of a nebula, then accordingly it will adjust all the settings and take the image. Uh, on the contrary, if it is only a photometric data, then it will avoid going into saturation and take the data where the saturation level is just before the saturation. They will it will take that, and then there is something called what that name. There's this saturation point of very for photometry. So at what saturation, what settings, or what exposure the saturation, the image will get saturated. That can also be, that is the area where the AI can be put to use. I think it will try to get the idea about the magnitude of the star, as well as the setup and sensor of the camera, and then it will automatically put the exposure and take the photographs and image and process the image accordingly. So all these things can be surely done using AI and ML in the next few years, I guess. And the second question, sorry, I lost that question. What was
can
that?
occultation through space telescope be used
Yeah,
to
yeah,
study
yes,
super
yes,
belt
yes. There,
objects?
yes,
And
yes, definitely yes, because there are some predictions, there are some proposals to JWST, James Webb Telescope, to observe remote objects and occultations by these objects, because sometimes these objects, uh, they are so far that uh, their movement is very slow, extremely slow. So within a month, even they cannot cross few arc seconds. So what happens is that if they are passing through a relatively blank area in the sky, there will not be more opportunities for occultation predictions for these objects. So this is the area where space telescopes can come into picture, because space telescopes can can be in a better position. Since it is above the atmosphere, it can put to use the fainter stars for such occultations, and still create more and more occultation opportunities. So that can be used. And these objects which are beyond the reach of the even big telescopes, that can also be observed. Their parameters can also be refined using space telescopes. For example, if you have there are some Kuiper belt objects, or SDO, that is scattered disk objects, which are very distant, and their observations are so less that the parameters, the Besselian elements on which their orbital parameters are computed, are unreliable. So more and more observations are required for such objects. And let me tell you that some objects are having apparent magnitude greater than 2022. So that is beyond the reach of some of the large telescopes. Forget about amateur telescopes. So that is the area where space telescopes can come into picture and serve. Okay. So tell me more. Okay. So I was coming to this diagram. Yet this is yet another beautiful application of uh, occultation science, occultation astronomy. So you can see these are occultation events, and these are successful occultation events, and this was exclusively observed by us. I mean, there was another group, we observed this, and then this was observed by professional telescope, that is 3.6 Devastal optical telescope. But this was an asteroid, and this was Pluto. And now you can see the difference in the light curve. Can anyone put in the chat box why this is so abrupt and this is so gradual drop? In this case, light was abruptly dropped as the occultation started, and abruptly it regained. But in this case, it was gradually lost, light was lost, and again it was regained gradually, and then it was restored. Any entries, any guess in the chat box? I'm not able to see.
Waiting for some responses.
Yeah. Okay. We'll wait for few seconds.
Okay, there are two responses. One is small object and high speed for sharp curve. Inverse applies for Pluto. There is maybe because of motion of Pluto, then there is difference in velocities. These are the kind of
Okay.
responses.
Okay.
And spherical, somebody says spherical and asteroid is not spherical.
Okay. Okay. Those may not be the important reasons. The most prominent reason for this is a clear signature of having atmosphere. See, if a planet is having the occulting body is having atmosphere, the starlight will gradually dim out as the limit the ending starlight reaches through the atmosphere of that object. The light will gradually fall. But in this case, there is no atmosphere, so light was abruptly dropped and abruptly reappeared. So this shows that although it was a much proven fact that Pluto is having atmosphere, but from this light curve also you can make out this thing. So this is where you can clearly see how occultation astronomy can give you a better idea about the planetary features. It is said that the next best way to study study an asteroid after direct space explorations is occultation. That means, just to put it in other words, direct exploration to that exploration of a spaceship to that particular asteroid would be the best option to study that object, no matter. But it is, as we know, that it is extremely costly, extremely time consuming, and we cannot send spaceships to each and every asteroid. So next best option is occultation, because by way of occultation you can know so many things about that asteroid. So lastly, I'll just show you one event, typically how it appears, that I would like to show. I'll have to share the screen again, I think, because only that screen I had shared. Okay. Okay, this is one occultation event that we
Sir, you will
successfully
have to
observed.
share the screen. You will have
Yes,
to share.
yes. I'm sharing.
Ah.
Is it visible? Okay.
Yes.
Yes. So a typical occultation event, one of the brighter stars was occulted. A 7.5 magnitude star was occulted in 2020, and we successfully observed it and reported this. So just wanted to show you how this typical event occurs. So duration of this event was 7.7 seconds. And the disappearance timing was this, reappearance timing was this, and this analysis was done by this software, Biotech. And there are many Python applications that can be used to analyze this data. So this I wanted to share. Okay. So I think that's the end of my presentation. Is there anything else? Any questions?
No questions in the chat yet.
Okay.
I will put the link of Akash Mitra Mandal also on our group, and so
Okay.
that there are other and other videos available that people can see.
Okay.
So I take this opportunity to thank Shishir sir for giving this, sharing your work and your team's work, and how, showing how an amateur astronomer can contribute into the knowledge. Okay, there is a question which says, can you show that video again? But I think I'll put that video on the group. Okay, so
Okay.
let me thank Shishir sir for showing that how amateur astronomer can develop a hobby. I mean, hobby is not just a pastime activity. Hobby needs to be developed, and of course, for that one need to have patience and focus all the efforts onto certain particular areas. And over a period, as you have shown that you have focused on different areas. So one thing at a time. There was a time when you focused on observing the SOHO sun-grazing comets. There's a time when you focus all your efforts on photometry. So this gives a very good example of how amateur astronomy can be developed as a hobby and contribute to the knowledge, now what we call citizen science. And thank you very much for answering all the questions. There were good number of questions, which would mean that people were listening and people were interacting and they wanted to know about this. Thank you very much, sir.
Thank you. My
And
pleasure.
thank you all participants. Please fill the feedback form, which I also put the link in the group. And tomorrow we will meet in the morning, not tomorrow, sorry. We will now meet on 26th in the morning, 10 o'clock. Okay, so tomorrow and day after tomorrow will be holiday, and now we'll meet. Our third day will be on 26th morning, 10 o'clock. We will have the next lecture. Thank you, sir.
Thank you.